Thomas. I'm a student here at AIM Manassas. Today we're just going to go over a flow-type carburetor. The main parts of it are your main metering system, you have your idle system, your float mechanical system, and you also have your accelerator and your equalizer. Those are the main things that I think are relevant. So how the system works, right? Carburetor is in Venturi, right? So when it's together, see here, you have a bigger open for the greatest pressure on your Venturi, right?
Mm-hmm.
And you flip it over, on the engine, it's a smaller hole diameter, which is going to cause a low pressure by increasing the velocity coming through. Right.
So you have your air coming from the back part.
Right. So
okay.
The air's coming in here, causing a high pressure, and your low pressure is coming out the back end, right? Causing more fuel and air to be sucked through. Okay. This will be mounted onto your engine, and this would be not.
Mm-hmm.
So pull this apart, right? So our main metering system, right? This is our main metering orifice, right? Screws in right here. So this is where the fuel would actually come out into the throttle body. It works in conjunction with the throttle itself and your metering, your fuel mixture control, manual mixture control, right? So this is your part of your mixture control. It would sit through here, and you have a valve going left or right, right? And it seats right here. So this whole chamber right here is filled with fuel set by the float type, right? As fuel is pumped up into here, as you can see here.
How does the fuel get in there?
Well, it's pumped in through the fuel line.
Okay, the fuel line. Okay.
Yeah. Fuel line here on the top.
Okay.
Fuel's added in through here and metered through this float type valve. Sits here, and your carburetor float sits here, right?
Mm-hmm.
So as fuel sitting in the chamber, as you enrich the fuel, you're opening this valve here, right? As you can see in here, there is a hole there, right?
Mm-hmm.
And your mixture control works in conjunction with that, right? As you enrich the fuel, you're rotating clockwise, and more fuel is being added into the system, right? Allowing it to be sucked in through here and come out the orifice here, right? So that's that. It's the main metering system. What that does, it provides air-fuel mixture at anything above idle. Okay. Then,
so for idle, what do you use?
So the idle system, it's different, right? So fuel pressure in the system here will cause fuel to be pumped through and up through this orifice right here, right? Mm-hmm. So this, as the throttle is closed, right? So you've created a high pressure here.
No, completely closed or nearly closed? Okay, because right. It's nearly closed.
Yeah,
okay.
High pressure here and a high pressure there, mm-hmm. right? So it's no longer going to be, the fuel is no longer going to be sucked through the main orifice. It's going to be sucked through that right there, the idle control needle, right? And this is how you control your idle, right? You would set it with the engine running to make sure it's the best possible and functioning idle. Okay. And then you also have your bleed air here on the other side. Mm-hmm. Okay. So that's idle and the main metering system. Okay. You have your accelerator assembly, right? Basically what that is if you do a high increase in power, right, what happens is this piston would be pushed down, forcing fuel through here and up into the throttle body, causing an increase in your fuel enrichment and power. Okay.
Okay, like in takeoff, or
right.
When do you need that? Okay.
If it's a slow increase of your throttle, what's going to happen is the fuel the piston will still go down, but it will just return to the main system. It won't be accelerated through the acceleration meter. Okay. So that's that. How the float works is you have pressure, your pressure regulator valves or screws on the top to release the pressure when you're taking it apart. But how these work together is you have to set, each manufacturer will have their own limits of how their float, where it's supposed to sit at. For maximum, I think it's 13/64 as it's sitting here. Okay, so what happens is if there's too low of a fuel in the system, your float's going to be down here, right? And you
Okay, your pin fell off. Okay.
yeah, the float will be.
You want to? Okay.
Your float will sit here, and the meter and valve will open. As the fuel level rises, this will push back.
Okay, sorry. Let me look at that again.
Yeah. As the fuel level is low, your float will be low. Will allow fuel to come through your float orifice or valve, right? Then, as the fuel level rises, this will rise and will close off and seat properly. Will allow no more fuel to be coming. That's that. Okay. So with the economizer or the power enrichment, right? How that works is what it does is it adds more fuel to the system at above 60 to 70% above cruise, right? So how it works is during cruise control, you're operating a leaner mixture. You don't need as much fuel, which actually saves fuel in the long run. But as soon as you increase the throttle, which is going to make it richer fuel intake, what happens is you're actually cooling the cylinders down with the more fuel you have.
Okay. Thank you. What of the idle cutoff? Do you have that?
So the purpose of the idle cutoff is basically stop the engine altogether. What you would do is you would work with your mixture control and you would temporarily lean out the engine to as low as possible to try to burn off all that extra fuel that you've put in there for takeoff, high power maneuvers. And you try to burn that off. And so you'll see a momentary increase in RPM, but then right before it drops. And that's when it cuts off. You just cut off all the fuel.
Thank you so much.
Yep.
Thank you.